Hi, and welcome to this introduction on installing and managing a self-hosted Ftrack studio in your facility. My name is Patrick Boucher, and I'm a technical consulting engineer here at Ftrack. Today, we're going to start with an overview of Ftrack's self-hosted solution and what's required to install and run it. Then we'll continue by building a small demo deployment so you can see everything in action. And we'll finish with some best practices and troubleshooting tips. Our documentation covers much of the content that I'm going to be covering in this talk. You'll be able to rely on this documentation as you embark on your own journey. It is pretty explicit. If you would like to follow along during this talk, you can go ahead and use this QR code right here and scan it, and it'll take you to the documentation. What does self-hosted mean, you might ask? Well, it simply means running and using a copy of Ftrack Studio that Ftrack doesn't host for you in the cloud, but that you maintain in your facility or your private cloud. Although this talk will include a demonstration of installing self-hosted Ftrack, the actual infrastructure that I'm going to use is going to be very different from what you'd use in production. However, the commands and techniques should be transferable to other environments. In the documentation, you'll encounter the words on-prem or locally hosted. These are all equivalents to the term self-hosted, which I'm going to be using during this talk. Why would you opt for self-hosting, given that Ftrack's cloud-hosted solution is already pretty robust, reliable, and universally accessible? Why would you take on that burden of installing it and managing it yourself? Well, some facilities may need an installation of Ftrack inside their firewall for security or compliance reasons. Maybe you're in a geographical location where your internet connection isn't reliable. Others might want greater control over the actual application deployment to satisfy their specific technical requirements. Whatever the reason, that's why Ftrack offers multiple installation solutions. If you choose to install self-hosted Ftrack, you should consider a few things. The standard offering of Ftrack Studio doesn't include the necessary licensing to run it in a self-hosted fashion. Instead, you need an enterprise agreement, which has a lot of advantages, but one of which is the right to a self-hosted deployment. It should be noted that you can benefit from the advantages of an enterprise agreement even if you plan to continue using the cloud-hosted application. I do encourage you to contact sales@ftrack.com if you'd like to know more about that. You should also be aware that by self-hosting the application, you're going to be responsible for the installation, configuration, maintenance, which includes backups. And that should mean that you should be minimally comfortable with some key technologies. Speaking of technologies, let's talk about the first iteration of Ftrack's self-hosted. It was initially based on CentOS infrastructure, and it involved installing each component of the solution individually directly on one or multiple servers. The last version of Ftrack Studio to support this deployment methodology was Ftrack 491. We've since moved to a deployment strategy that leverages containers and container orchestration. This new strategy allows for much greater availability, scalability, reliability, and flexibility in your deployment options. More specifically, we use Docker containers orchestrated by Kubernetes. To ease the management of this, we also use Helm, which bills itself as the package manager for Kubernetes. Finally, our documented instructions use CentOS 7 to underpin all these technologies that I've just mentioned. The beauty of Kubernetes is that wherever it can run, you should be able to run Ftrack Studio. So instead of running Ftrack on-prem on your own hardware, you can run it in private clouds such as Google's Kubernetes engine, Amazon's Electric Kubernetes service, Azure's Kubernetes service, or any other managed system. The Ftrack application includes multiple services that all work together to provide a scalable system. Kubernetes makes managing and connecting these various components much more straightforward. Let's look at them one by one separately. Let's start with NGinx. NGinx is an open source application that can have multiple replicas in the cluster. It's the entry point for the Ftrack application, where it'll serve up static files and it'll forward traffic to 4 other components, namely the server, event server, thumbor, and sync components, which we'll talk about later. The NGinx component connects directly to a persistent volume for data storage of static files. These static files include things like HTML and JavaScript files, of course, but also the video and image media that you're going to be uploading to Ftrack for review. Next up, we have the server component. The server component is supplied by Ftrack, and it can have multiple replicas. This is the component that simply implements the Ftrack Studio backend logic. It's the API server. The server connects directly to the database and the persistent volume for data storage. Next, we have the event scheduler. The event scheduler is, again, a component supplied by Ftrack. Operations that need to happen on a schedule are published by the event scheduler for processing by workers. Things like daily digests, cleanups of failing long-running job will run through this process. This component publishes events directly to RabbitMQ. Next up, we've got Thumbor. Thumbor is an open source application that can have multiple replicas inside your cluster. This component creates thumbnails on the fly for display in the GUI. And once generated, the thumbnail is cached for faster delivery. This thumbnail cache is basically stateless. It can be destroyed if you want. Like everything inside the Kubernetes cluster, which is stateless, if a thumbnail that doesn't already have a cached version available is requested, Thumbor will just create it on the fly. Next up, we have the event server. The event server is another component that is supplied by Ftrack. This component serves events to the Python API's Event Hub via WebSockets. It's a layer with access controls over the internal Ftrack message queue. The event server connects directly to that internal message queue, which is a RabbitMQ queue, and forwards specific messages to connected clients. Speaking of RabbitMQ, RabbitMQ is an open source application and is the message queue for the entire system. There are 2 separate queues. The event queue is published to by the server, and it's consumed by the event server to forward messages to connected API consumers. And the work queue is published to by the server or scheduler, and it's consumed by workers and image encoders. Next up, we have the worker. The worker is again supplied by Ftrack and again can have multiple replicas to handle bigger loads. This component runs long-running processes that need to run outside the normal HTTP request response activity, which the server component handles. Things such as report generation, sending out email digests, cleanups, all run through workers. And we have the image encoder. Again, the image encoder is supplied by Ftrack, and it can have multiple replicas to handle load as well. It converts and encodes playable media that you upload to Ftrack. It will connect directly to the RabbitMQ message queue to receive its jobs, and it will then process the uploaded media so that it is readily available for playback over the web. Next, we have the resolver. We have the resolver component. The resolver is an Ftrack supplied component that is used by the Ftrack location system. The resolver generates the full path of a component for a specified location. The built-in resolver that we're talking about here will only resolve components for any of the built-in Ftrack locations. If you have a custom location that you've implemented, you will have to supply a custom resolver plugin via the Python API to resolve these custom locations. If you want to know more about the location system, we have another webinar that was made by one of my colleagues that explains the system, the location system, a little bit more in depth, and it will be linked in the material accompanying this webinar. Next up, we have the sync service. The sync component supplied by Ftrack. This sync component underpins the synchronization of review sessions, and it ensures that the state is shared among multiple users in a single shared synchronized review session. So as one user annotates or scrubs on the timeline, these actions are synchronized among all the users of the synchronized review session. And this is the component that manages this. And then finally, we have the upgrade Ftrack database component. This one is a little bit different than the others. It is supplied by Ftrack. And what's different about it is that it will run once during a Helm install or upgrade operation, and it only communicates with the database to set it up or upgrade it, and then it exits. It's the component that will run database migrations on application version changes. You'll notice that the cluster components themselves don't include the database server. For production setups, we strongly recommend that a dedicated server be supplied by you that Ftrack will connect to get its database. This database, which is required to be a MariaDB instance, can be in a virtual environment if you provide it with fast enough disk and reserved host resources. But for a production setup, we do suggest it have its own server. All right, let's dive into a demo and show all of this being installed. The different steps to installing this solution and getting Ftrack up and running. First, we're going to make sure that we have a working Kubernetes cluster. Then we're going to set up and initialize our database. Next, we're going to install Ftrack itself. And then for bonus points, we're going to finish by enabling HTTPS on our Ftrack Studio server. As I've covered previously, to self-host Ftrack, we're going to need a Kubernetes cluster. In a production environment, you'd probably have your cluster or use a cloud Kubernetes solution, such as the ones provided maybe by GCP, AWS, Azure, just to name those. Our documentation shows how to set up your own Kubernetes cluster using K3s on a CentOS 7 server. Luckily, modern Docker desktop has a Kubernetes cluster included. So for this demo, I'm going to be using that along with the Kubernetes command line tools, which I've previously installed using Brew, which is a package manager for macOS. Yes, this is all going to be running on my Mac laptop. All right, so first off, you would have to install your various tool chains, namely the Kubernetes command line interface. And this is the command that I had used previously to install the tools on my computer. And you can see that it is already installed and up to date. You would also need to install the Helm tool that is also already installed on my system here. Depending on which system you're installing your cluster onto, the tool chain installation will be vastly different. I used Brew. You might be using something different. For example, our documentation helps you install these tools directly from their respective websites instead of using a package manager. Because you might be installing on any operating system. We wanted to have generic install instructions instead of dealing with individual package managers. Now that we have our tool chain, and that by virtue of having Docker Desktop installed, we have a Kubernetes cluster, let's confirm that our cluster is up and running. So to do that, we can run this command here, which will list the system pods of the cluster. Now we can see all these system services that are inside the cluster, and we can see that they're all running. So we do have an operational cluster, and we are confident that we can move forward. Definitely, as you're installing your cluster, make sure that you can run this and that everything is as expected before moving to the next step. Now that our cluster is up, we're going to give it an ingress controller. This is going to allow connections originating from outside the cluster to access resources inside the cluster. Depending on how you're deploying your cluster and how you're installing it, you may not need to do this. For example, K3s, which we use in our documentation, already has an ingress controller bundled, so you wouldn't have to do this independently. In my case, Docker Desktop's Kubernetes cluster does not have an ingress controller. So let's go take a look at what that would look like if we were to try to access it. So this URL here just simply points to my Kubernetes cluster. And if I try to load anything, I'm not getting a reply. It's just total silence. I don't have an ingress controller, so that's why this looks like this. Let's go and install it. So we're going to install an NGinx ingress controller using our Helm command. We should be able to switch back to our browser And now we get a different behavior. And this behavior is different because now we have the ingress controller that can answer our request at the entrance of the Kubernetes cluster, but it doesn't have any service that it is exposing. There's nothing behind the ingress controller to give you any web page or data, so you get this 404 message. This is actually a good thing. You've got a cluster and an ingress controller, and they're working. Now we just need to put some stuff behind it. Before we go ahead and install Ftrack, we're going to need a database server. So we're going to go prepare for that, and we're going to prepare for that by downloading a database file. Now this database file contains the schema for the database, but also contains some demo data so that you've got something to start with and you've got something to explore once Ftrack is up. Now that we've got that data, we're going to go ahead and we're going to spin up a MariaDB database. We're using Docker, so let's continue using that, but you'll notice that I'm using the Docker run command. I'm not using a Kubernetes command. That's because the database isn't going to be in the cluster. As explained earlier, I'm simulating having the database outside of the cluster, but still leveraging Docker. So we can see, if I just switch over to Docker, we can see that we've got our MariaDB instance running here. Now, we can go into the database and initialize the data. What we're going to be doing here is we're going to be creating the database, but we're also going to be creating a user and some privileges for that user. Now I'm just using generic usernames and password as taken from our documentation, but in your case, you would be changing this to use a proper username and password that isn't out there in the internet, and you would make these commands your own by tuning them. And the last command here is to load our demo data and our schema inside the database. There we go. Now I can just quit out of this. Now, before going further, we'd like to make sure that things are working properly. We'd like to make sure that from inside our cluster, we can actually access our database that is outside the cluster. So to do that, we can spin up a MariaDB pod inside the Kubernetes cluster and drop ourselves into the bash shell in there. And then we can run a MySQL command to connect to the MariaDB server that is outside the cluster. And we're getting the list of usernames that are present in our newly initialized database. So this means, and this is the great news, that so far we have a working Kubernetes cluster that can access a working database with an initialized database. All right, we've got the functional prerequisites. We can move on to installing Ftrack. If this hasn't worked so far, there's no point in going to further steps. The requirements aren't satisfied. You won't be able to install Ftrack. If you can't query the database this way, there's something wrong, and you'll have to troubleshoot that. In our case, we're all good, so I can exit out of this database, and we can continue moving forward. Now, our next step is going to be to download the release of Ftrack Studio that we're interested in installing. I'm going to fetch the latest. If we go back to our browser in our documentation, there's a releases page. In the releases page, you've got these URLs that represent Helm charts that you can download. These are the Ftrack releases. I'm going to download the latest one, but I'm going to download it directly from the terminal. And I'm going to download it using curl. There we go. And if I list what I've got here, we've got our database data that I downloaded previously, and we've got our Ftrack package that I have just downloaded. Now, before we keep moving forward, we can't install Ftrack right away, even though we've just downloaded the Helm charts. What we need to do first is we need to create a file called ftrack.yaml that has some configurations in there that will allow us to customize the installation of Ftrack Studio to our needs. Luckily, I've got one that we can just walk through that I've prepared previously. Let's just copy that out. And go ahead and edit it. Now let's run through this file to see what the options are and how to fill them out. First off, the secret up here. The secret can be anything of your choosing. In our case, I've just decided to use a random UUID, and this is something that our documentation suggests. You can just generate one. You could drop into Python and use the UUID module to generate a UUID and just print it out to the command line. Once you have the UUID, just copy paste it into your ftrack.yaml file. The URL should be the URL that you're going to use to access your Ftrack site. This isn't related to DNS or that kind of stuff. That has to be set up independently. This is basically about Ftrack knowing where it lives and being able to generate URLs that represent its location. Next up, we have the ID. The ID is related to your Ftrack license. You can choose to pick one and then provide it to Ftrack support so that they can generate your license, or you can have Ftrack support or account management just choose an identifier for you that they will give you when you ask for your license. In my case, I've just decided to use this ID that is basically my domain name. You then specify your database's access configuration, access options. At the very least, you're going to need to specify the host. In this case, it is the host of my running Docker so that it can reach the MariaDB inside Docker. You would also here, you would input your username and your password to access the Ftrack database in MariaDB. In my case, I'm just using the defaults, the same defaults that I use to create the database user that are in the documentation are actually the defaults here. But again, I suggest that you use your own. Next, we're going to need to specify where Ftrack will store its files. Let's talk about storage for a bit. Ftrack is going to need storage to operate appropriately. And first off, your database will have its storage, which should be local to the database. The next type of storage that the Ftrack application is going to need is disk storage for any media files that are uploaded to it, like images or movies. Ideally, this disk space is going to be NFS mounted, so that as you scale the number of pods to match your usage of the application, each pod will have access to the same data pool to write new content, and then maybe another pod would serve out that content. Ftrack only stores files required for review or thumbnails. You should store other content like your actual work product in your facility's central storage, and Ftrack can hold simple pointers to those files if you choose. Ftrack is a review and approval and project management system, and it doesn't exist to store large quantities of arbitrary data internally. While we're here and we're talking about data, let's download the data demo data that our initial database holds references to. There we go. So we're going to make a data directory, and we're going to make a temp directory in there. We're going to go get the actual data files. Now, we've fetched the database data previously. Now we're actually fetching the media, so that when we're browsing around in Ftrack, we'll be seeing projects and we'll be seeing a reviewable media. But then when we actually press play to view it, these are the files that will be served up to us, movie clips and image files. Now let's go ahead and uncompress this data. All of these commands exist in our documentation. And we will change ownership and make sure their permissions are good on this data. All right, now that we have our data and we've talked about storage, let's go back and continue on in our ftrack.yaml file. The next thing that we are going to supply here is the image registry password. The image registry password is a password you need to request from Ftrack. This will allow you to access the Docker container images that will be downloaded and installed in your cluster. If you're running an air-gapped cluster where you don't have access to the internet, you can set up your own image registry and specify how to access that registry in these options. This is arguably a more advanced scenario, but just know that we support it. You would download the images using the registry password that we'll give you, and then you would move that to your own registry and it would work fine. Next up, we have the replicas section. This replicas section allows you to scale your deployment on a per component basis. For this demo, we're going to leave everything at 1, but for a production installation, this could be scaled dynamically based on CPU usage or based on number of requests or any other metric that you're tracking. That's the beauty and power of Kubernetes. So now that we've set up how we want our Ftrack application to be installed and configured, let's actually use Helm to install it. Now, this usually takes a little bit of time. Our documentation has this command with a timeout of 15 minutes. I've just put it in here with a timeout of 30 minutes because this is running just locally on my poor little laptop. So this is going to take a while. So let's see if we can track the progress of this operation. We will open up a new tab. And let's go look at the pods. So we have one pod. It is a pod of upgrade Ftrack database, and it is running. So we're off to a good start. The database upgrade is running. We did have initialized data in our database, but now this upgrade pod is running migrations to make sure that the database state is what the application expects it to be at the particular level, at the particular version of the application that we're installing. Once this migration step is done, the other pods are going to start spinning up. Let's actually open up a new tab. And we are going to look at the details of what's happening inside here. So kubectl logs to trail the logs, logs-f to trail and follow the logs, and the name of our pod that we want to look at. And we can see the migrations that are running on our database. Now I'm just going to stare at this, and through the miracle of editing, I'll see you in about 20 minutes or so. And we're back. Success. It says so in the shell right there. But success of what? Success of all the migrations running and having updated our database to be the proper form, the proper schema for this version of Ftrack that we've just installed. So because it got a success and because the migrations are done, the pod actually just stopped because it is just the upgrade pod, and we got back to our terminal, which means that if we go here and we look at our running pods, we can see that we've got a bunch more running pods. The upgrade Ftrack database is now completed. We've got 0 of 1 ready. And all the other pods and services are up and running, ready 1 of 1 and running. So this means that we should be able to access our Ftrack site. Let's switch over to our browser and see if we can do that. Now, what was 404 previously? If we reload, we get an Ftrack site. Excellent. Now, let's try logging into this. If I use the right username and password, we should get in. And we've got a functioning Ftrack site, functioning, kinda. We now have a license warning at the top, and we don't have much else. This is because we do have a functioning Ftrack site. All our infrastructure is running, Kubernetes is up, we've got a database, we've got the application installed, all our pods are running, but we actually don't have an Ftrack license. At this point in time, if you were doing the installation self-hosted in your facility, you would reach out to either Ftrack support or your account manager, and you would get a license file, and that license would come with either the ID that you've chosen in your ftrack.yaml or an ID that's being supplied to you that you will put in your ftrack.yaml. In my case, I already have a license that matches the ID that I had put in my ftrack.yaml file. So I'm going to go just fetch that real quick and copy the license out, paste it here, validate it. It is a valid license. Now if I apply it, it was successfully applied. Close that out and it'll reload. And now that I am licensed, I have a fully functioning Ftrack site. I can go to my overview. We could go into the projects. We can go into our demo project. Let's go to our versions tab, and we're going to try to play back some media. There we go. We can play back some media, and let's go into the sidebar here, go into the compositing task for this media, our versions. Let's try to upload another version. Where do I have my media? There we go. Let's just choose a color wheel. And there we go. It's uploading. We've got a background job. The background job just finished. And we've got a thumbnail for this new version. And we've got playable media. So all the components are working. The NGinx component just forwarded traffic and served up a media. The server is there to get us our data. The Thumbor worked, the image encoder worked, everything is connected to the database. We've got a functioning site. This is awesome. Now you'll see that we're accessing this site as HTTP. And at the beginning of the talk, I mentioned that we would go for bonus points and we would secure this as a HTTPS. Now, you can get an encryption certificate in any number of ways to encrypt a site to enable TLS and HTTPS. You can purchase the certificate, you can self-sign your own, or you could get one for free from an issuer like Let's Encrypt. This is outside of the scope of this demo, actually getting the certificates. But let's just say that you can use tools like Lego, like CertBot, like KCert to help you automate the usage of free Let's Encrypt certificates. I have mine, so let's just use those. We will switch over to our terminal, and let me just quit out of that. And I'm going to copy my certificates from my little oven. This is like a cooking show where everything is already prepared in the oven and you get it out without cooking anything or cooking time. So I've got some demo certs here, and we will add the certificates into our Kubernetes setup by creating a secret. Now that our secret is created, we're going to go ahead and edit our ftrack.yaml file. And in here, there is a section called ingress that we will just uncomment. Now, let's remove this. Now we're enabling TLS on the ingress controller, and the traffic between the browser and the ingress controller of our cluster is going to be encrypted thanks to the certificates that we have just we've just input. Now, another thing that we need to change here is our URL. Our URL here is HTTP right now. And now this is going to change because it's going to be encrypted. So we are going to add an S here, and we've updated our ftrack.yaml file. Now we're going to run Helm again because we've only changed our configuration file. We've not asked the cluster to pick up these changes yet. So we're going to run a Helm upgrade command. And this isn't really an upgrade, it's really just pick up a new configuration because it is the same version of Ftrack with the same Helm charts. We're literally giving a do not upgrade flag here, database.autoupgrade equals false, so that it won't run the migrations that it wouldn't need to anyway. So it's really just reconfiguring the existing pods. And we can look at what happens. We can see that we have a bunch of pods that are terminating. We've got new pods that are spinning up. These are the new pods that are reconfigured. Now let's break out of this. This is going to happen pretty quickly because it is a pretty simple change and Kubernetes is meant for this. We're going to switch over to our browser. And now if we go HTTPS instead of HTTP, we have a working Ftrack site with an encrypted connection between our browser and the self-hosted Ftrack instance. Again, we can browse around, we can view media, and let's test if we can upload media as well. Browse it, color wheel. And there we go, encoding. We've got the background job for encoding, and we've got our thumbnail and our playable media. So everything, all the systems, again, work fully end-to-end and are all operating in this new encryption, with this new encryption. That's it. That's really all there is to it. So let's go back real quickly and review what we've been doing and all the steps that we've gone through. So first, we installed a working Kubernetes cluster. In this case, Docker Desktop had our back and helped accelerate things for us. We installed a database server and initialized it with a schema and some demo data. We made sure everything was working before moving forward. We downloaded the Helm charts for the latest release of Ftrack. And then we created our ftrack.yaml config. Once the YAML config was done, we installed Ftrack. We installed our license for Ftrack to unlock Ftrack's capabilities. And then we installed HTTPS, or configured for HTTPS along with our certificates. Now, there are some gotchas. At the beginning, we said that we were going to talk about gotchas and troubleshooting and a little bit of tips and tricks. Some of the gotchas that we see most often are listed here. Making sure that your cluster is up first is something that people have stumbled upon. Going a little bit too quickly, not confirming that the system pods were up and that they could communicate with them, or not confirming that they had an ingress controller. Making sure that the database is initialized correctly as well, and that you can access it from inside your cluster is something that have caught some people a little bit flat-footed. It should be noted that if a Helm install fails, for Ftrack or anything else, if a Helm install fails, it is possible that you may need to uninstall before being able to reinstall or configure, depending on the type of failure. In some instances, let's say that you try a Helm install of Ftrack and your database wasn't responding, or it couldn't connect to the database. The pod for the database upgrade will actually spin up, but won't be able to connect and will fail. And in this circumstance, that basically leaves you with a non-working Ftrack installation. And oftentimes it's just easier to uninstall and reinstall. We mentioned it really quickly in passing at the beginning of the talk. Everything is stateless. So barring whatever downtime is going to be required, you can tear down and uninstall Ftrack from within your cluster and reinstall it. Everything that requires state, everything that requires to be permanent, that is required to be permanent, is in the storage and in the database, which are not in the cluster. Uninstalling can take a couple of minutes. Check your pod states before you try to reinstall. If you still have pods that are running and the uninstall hasn't completed yet, you're not gonna be able to reinstall again. The 404, this is something that we deliberately looked at that 404 in our demo installation. getting a 404 from NGinx is actually a good thing. If you're getting a 404, but you've already installed Ftrack, that's weird. Maybe your ingress controller isn't configured correctly. If you're getting a 404 and you have not yet installed Ftrack, then that might actually be a good sign that you do have an ingress controller, versus having just a blank browser that can't reach your cluster. So a few gotchas that are very infrastructure and Kubernetes related in regards to installing Ftrack Studio. Next, there are a few important or useful commands that I've got listed here. There are some commands that have been used in the demo and that are in the documentation. Get pods will get you a list of what pods you have running in your database, in your cluster at that given time. Describe a single pod or describe multiple pods will actually get you the full description of how those pods are set up. It's a lot of information, but it's a lot of very important and practical information. The same way you can describe your pods, you can describe your ingress controller, which is useful to understand, has it been configured properly, which ports is it exposing, which services is it exposing. Key command is also kubectl log to get the logs of any running pod. And one that we didn't use today because Docker Desktop doesn't allow for it, but kubectl top pods will give you information, performance information of the currently running pods, things like CPU usage, for instance, which can help you understand if you need to scale with multiple replicas certain of the components. And finally, Helm uninstall. We've installed a bunch of stuff today, but definitely Helm uninstall is also useful to get you out of a bind, for example. If you need to contact support, like I said at the beginning of the call, at the beginning of the webinar, you're expected to understand a lot of these technologies because maybe you're going to be tweaking the Helm charts or tweaking, or you have an existing cluster with different namespaces. Kubernetes is a very malleable system, and you might want to own it. You will have to own certain parts of it. Definitely, things like backups come to mind. Even if that's the case, the support team is obviously still here to help you out should you need that. If you do contact support, I highly encourage you to include stuff like the list of pods and their states in your cluster, or at least in the namespace for Ftrack, the pod descriptions, the ingress controller descriptions, any logs that you've found that you think might be suspicious, and definitely a description of what you've tried already. All these things, if you can get them in the support conversation at the very beginning, are going to be very useful. This brings us to the end of our little introduction to self-hosted Ftrack Studio. I do hope that you got a lot out of this. It's a pretty packed demo. The documentation outlines all of the steps that I've gone through on different infrastructure, but you'll see that the patterns are very, very similar. And I do hope that this helps you install your own Ftrack locally, or helps you understand what's going to be required of you if you were to consider installing Ftrack self-hosted for yourself and your facility. So with that, thanks for being here, and I hope you got a lot out of it.